Continuing right along with Essential Mathematics for Computational Design, running through the handout that comes free online on Grasshopper 3D. It's the 4th edition by Raya Isa. We're into Chapter 2, which is Matrices and Transformations. And I never really, I remember matrices and identity matrices and what I was potentially doing. I just never really thought about programming it in. So what I'm going to do here is I'm actually going to leave the Python script for a second, pull over the Grasshopper script, and show you how to build a node-based script for jumping in and grabbing. What I did was a bounding box and just set dimensions on it. I actually put I put a center box. I put a bounding box around it. I found its center, and then I basically anchored a vector. And for some reason, I took out the move of that. I do need that now, so let me slide that back in there for a second. Grab a little move factor, move that up in the Z direction possibly, and we'll just move it up by 32. Yeah, that's going to make a little more sense. And then if I take that into my bounding box, you'll see that I actually have a box that's up in the air. I found the center of that. I go back to the point of origin, and then I build a vector, and I'm able to draw the vector pointing back from that box to where the center was. So that's it. That builds a vector. In doing so, if I apply that to the geometry in a move, I can just pop in what I was having trouble understanding before, a transpose matrix, which has to be 4 by 4. Looks like an identities matrix down the middle, but then you can see the adjust that's happening from that. As I do that, I'm moving it. You have to have a negative 32 here. So you start to realize, hey, I could be building these geometries. These matrices to affect things. Most transformations are handled by a 4 by 4 matrices, at least they say in this section of the book. What I ended up doing was then doing a rotation. I put it into radians, so I have 0.25 pi. And you can see what effects there. And these are sines and cosines coming to play in here that are, I think it's cosine, negative sine, theta, or whatever angle you're dealing with. So you start to see how that has an effect. A scale works the same way. You see that shrunk down to 0.202. And you can see the fact now it's shrunk down to 0.4. So you can see how that happens on the X, Y, Z going down to the identity matrix. So think about it. You can actually start to make matrices to handle information. I'm definitely going to start using this. Every time I talk to engineers, they're always like, do you deal in matrices? Do you deal in matrices? I guess I haven't. I've been dealing in lists and lists of lists and data trees and all that. The inverse matrix is pretty cool. It just pops that in, and you can see we had a negative 32, and it inverses that to 32. My kids are coming in to make a lot of noise. That's Ella behind me. She's fine. The other thing to do is to think about taking that scale factor, 0.4, and think about taking that angle factor for the rotation and take those two and bring it into a node on the Python script, which is what they teach you how to do. And you can put this all into one matrix. So you can do it all at once. This is incredible to think about what this is going to do for your geometry. And I'm going to make it a pleasant color blue because I love blue. And it's like, if I can go in here and grab a series of boxes that have a certain amount of counts on how many are 1, 2, 3, 4, I have to be very careful with this that I go in and change all the names to what they need to be. Keep in mind, if you take a note here as I right-click on this node up on geometry as a variable, and let me just leave up everything. If I right-click on that, you're going to see it not only has the type hint of, I wanted to go on the geom, a type hint of going to the geometry base. I also have to be very careful of just going in here and looking and saying, am I dealing with a list item, an item access, a list access, or a tree access? And I have to make sure that I have a list access because I have 4 boxes. So you've also got to check that. This one, as I right-click, you'll see it is an item access, and the type hint's going to be a float. Same goes for this one as well. So you're going to have a single item and a type hint float. Once you get that all up and running and you pull it out, if you write a nice script like this, which is pretty simple, and we'll run through it, you skip over all this and import Rhino. You want to move to origin and find center. So you make a variable center, which is rhino.geometry.3.3d.unset. And basically, you're finding that. And then if geometry count is greater than 0, so we're going to start with that. And we have 4 items there, so definitely it's going to be greater than 0. It's going to run through the script in these iterations, and it's going to take a bounding box equaling the geometry of list item 0, index 0, and get bounding box true. Then you're going to go through these iterations from I in range. So 1, 2, 3, 4. And you're going to follow this script and do that by bounding box union geometry index I, which will be 0, 1, 2, 3. And then get bounding, or 1, 2, 3, 4, will get bounding box true. And then you have center equal bounding box dot center. So there's the little script that's going to basically do what you need to do to get each of your boxes to do what you want them to do. And then, looking over into here of what's happening, you have a matrix coming out. You can see the effects of that are being affected in the data that you could have typed in separately on a move, on a rotation, on a scale, on an inverse, but you can do that all in one right here. So then your origin is your rhino.geometry.3d.org, and you're going to create move transformation matrix, and move 1, there you go. You're going to translate, and you're going to have that kind of vector thing happening with origin minus center. So you can do your transform, you're going to do your transform translation, which is just the move, rotation, which is the rotation, scale is the scale, and then basically 1, 2, 3, 4 as you go through it, and you get a little identity matrix out of the end. Try get inverse. All these blue items are functions that come right up when you start typing Rhino dot geometry dot transform dot, and you're going to end up have these come in. And then the matrix is going to be a multiplication matrix of a 4x4, I guess, times a 4x1 or whatever. So you got, they're going in reverse order, which I find interesting. 4 times 3 times 2 times 1, which gives you the data, and boom, 4G in genome, G transpose matrix, and you're done. You got a matrix and you got a geometry coming out of it. Pretty outstanding. I don't know how much I mean, I'm starting to wrap my head around it, but what the best thing is I know I can pack from knowing, looking at these matrices, remembering from grade 10 and grade 12 matrices in geometry, what they did to similar triangles and moving around things on my graph paper. I can start thinking of that. And as I play with these numbers, as long as my script's working, I can do a ton of things with this visually and turn, numbers into all these geometries. I think it's fantastic. And why not rely on some of the script that you can pull from the other script as well? And like I said, all of those scripts come with the GH file that they're putting online for you. You simply go in, you grab it, and actually it's this one, bottom one. You zoom out and you realize you have everything. So we're basically flying. They give examples at the end of dealing in vectors. They give you the examples of the lifts, not only in Python, but in C and in VB script. And now we're going to go on the NURBS curves and have a lot of fun dealing with all this data as we get plugged all the way through until we get down to some of the scripts in the end we're going to have fun with on, hopefully we have some interesting VB scripts and C scripts. Yeah, there's Python script, and there's the C script, and there's the VB script. We're going to play with the NURBS curves. Anyhow, so it's kind of exciting, and I've got nothing there but my old image that was still there coming from this file. Let me go back into where I was, and there we go. It's understandable. The booklet's there. You can grab it online. I'm going to be going into, it's the Essential Mathematics for Computational. I printed it off because I can't stand trying to have another screen up teaching this as I scroll. I'm a paper person, and I'm going to stick with it. So we're going to go into parametric curves and surfaces next. We're going to have some great examples. 3 on vectors, 1 on matrices, and a couple more on NURBS curves and surfaces. Thanks for watching.